All right. So yes, Pratish. In that test, I'll be like launching polls, and then through that poll, you have to respond. Okay, and then you have to be very, very honest in that test. It can't be like, okay, even if you're getting wrong answer, will be saying minus or +4. That test will be only for honest guys, sincere guys. Okay, because those tests, the test which will be conducted for you, that will be for you, right? So you have to be like honest with that. Okay, I know that, Pratish. Correct. Chetana, I have already announced that tomorrow there will not be any physics class. Okay? Tomorrow there won't be any physics class, and Saturday will be a live test on kinematics. Okay? Mixed है उधर, आज दोनों होगा, ठीक है? चलो अच्छा. So let us talk about the problems that we have faced while explaining photoelectric effect using wave theory of light. Okay, so there are three problems. There are three major features of photoelectric effect that cannot be explained in terms of classical wave theory. Okay, वो क्या है बच्चा लोग? So the first problem was what? The intensity problem. Wave theory suggested that if intensity of light is increased, or if intensity of light is high, the energy of the wave will be high. But this was actually discarded using the photoelectric effect phenomenon. So when this photoelectric effect was observed experimentally, so it was observed that if you increase the intensity and if you actually keep the frequency below a certain limit, what will happen? No photoelectrons, no electrons come out of the surface. That means the energy is not related to intensity, but with the frequency. When we have increased the frequency, then yes, and electrons have come out of the metal. And when we have increased the intensity after that, the number of electrons have actually increased. So that have given us a kind of sense that energy is not related to intensity but frequency. And then we actually gave a photon theory of light, that light consists of photons. Okay, and number of photons is what actually related to the intensity. Okay, bachalo. Guys, is it very disturbing? Is it disturbing? Okay, wait a minute. 1 minute, John. Don't worry, guys. That will be sorted out within a minute. Okay, so I've already asked them not to do this. Viresh is saying it's like giving rhythm to what you are speaking, sir. Okay, okay, don't worry. I think that will be stopped in a minute. तब तक ले थोड़ा सा मजा करो, ठीक है? पीछे से dam. चलिए, anyway. So yeah, the first problem is what? The intensity problem. The relation of energy with intensity. So how the photoelectric effect depends on intensity was not successfully explained by wave theory of light. तो ये पहला प्रॉब्लम आया, ठीक है? दूसरा प्रॉब्लम क्या है बच्चा? फ्रीक्वेंसी का प्रॉब्लम, जो एनर्जी से रिलेटेड था. Like sorry, this was actually according to wave theory, photoelectric effect should occur for any frequency of light, है ना? For any frequency of light, provided only that light is intense enough to supply the energy needed to eject the photoelectrons. But it was not like that. So concept of threshold frequency was not like successfully explained using wave theory of light. So यहाँ एक problem आया. So the problem of frequency was what? This concept of threshold frequency was not actually explained properly using wave theory of light. This was the second problem. All right. Third problem क्या है बच्चा? Time delay का problem. What is this time delay का problem? So if energy acquired by photoelectron is absorbed directly, from the wave incident on the metal plate, the effective target area for an electron in metal is limited, probably not much more than that of a circle of a diameter, roughly equal to that of an atom. So in the classical theory, the light energy is uniformly distributed over the wavefront. Thus, if light is feeble enough, that means like enough above that particular work function, there should be a measurable time lag between the impinging of the light on the surface and the ejection of photoelectron. सिंपल सी बात है, उन्होंने क्या बोला कि जो भी आपके पास मेटालिक सरफेस है, whatever the metallic surface you're having, if light is actually incident on it, let us say this is what a small area, right? On a small area, let's say the light is being incident. So from here, the energy will be what actually distributed all over the surface. So the moment we actually impinge the light on the surface and the moment when the electrons are actually coming out, there should be at least some kind of time lag between these two phenomena. But when we observe photoelectric effect, we don't actually analyze, we don't actually see this kind of time lag. This time lag was not properly explained using wave theory of light. This time lag को क्या बोला गया बच्चा लोग, किसको अच्छे से हम लोग बता नहीं पाए. However, no detectable time lag has been ever measured. Now, quantum theory solve these problems. What is quantum theory, बच्चा लोग? तो you will study this quantum mechanics, quantum physics in detail in like later classes. Like if you're studying BSc physics and all those things, you'll study the quantum theory. ठीक है, जिसमें dual nature को assume करके काम करते हैं. So can I say that to explain all the nature or to explain physics properly, theoretical physics or any physics, the correct way to explain it is what? Quantum theory. ये क्या करेगा आपको? ये दोनों nature को क्या करता है? Combine करता है. This theory what actually combine both the nature, particle theory also and the wave theory also. Okay, solve these problems in providing the correct interpretation of the photoelectric effect. If someone asks you which theory solves the problem or actually explain photoelectric effect completely, particle theory, wave theory or quantum theory, so what is the answer? Quantum theory. क्या बच्चा ये आपको explain करेगा. To explain this time delay problem, we can assume this. देखो, मैं छोटा सा example देता हूँ. How energy can be distributed or you can say be given to a system. इसका दो तरीका है, ठीक है? दो तरीका क्या है? So this particular analogy has been given in HC Verma also. You can see this particular analogy in HC Verma also. Consider you are having some herbs, ठीक है? आपने कुछ मान लो धनिया जानते हो ना आप लोग? चलो धनिया का पत्ता, green leaves, right? You know this, right? Let us say you have like in this like winter season, you are cultivating this dhania, ठीक है? Or any herb, यार, छोटा सा, some small plants are there. You are working on your farm and you are, let's say, having some small plants. You are trying to irrigate them. You are trying irrigation. तुम क्या कर रहे हो? Irrigate करने की कोशिश कर रहे हो. Okay? Yeah, bag of water hypothesis, correct. So what will happen? You can irrigate this using a hose pipe. आप क्या करोगे? You will take a hose pipe, right? You'll connect this hose pipe with a what? A tap water. आप इसको क्या कर लोगे? आप इसको tap water से connect कर लोगे. Let's say this is the tap water. You connect this with a tap, ठीक है? आपने इसको connect कर लिया. And through this, you are actually irrigating this. So how the energy will be distributed here? बोलो बच्चा लोग. How the energy will be distributed here? बच्चों से काम नहीं कराते. So these plants will be irrigated slowly. So these droplets of water will come and give the energy. Consider them as the energy. These droplets of water will come continuously and it will take time to irrigate this. है ना? So these droplets of water will come here and then irrigate this. Correct? What is the other way? Other way क्या है बच्चा? तो क्या करेंगे? होली का वो बलून निकालेंगे. पढ़ा है ना आप लोगों ने? मैंने बताया था आपको. Consider what? Yeah, small packet of energy. ऐसा कि फटेगा तो पूरा. तो consider what? A balloon. Sorry, बहुत गंदा बलून बना. ठीक है बच्चा, तो ये मान लो ऐसा कुछ आपके पास बलून है filled with water. You're having balloon filled with water, and you just throw these balloons filled with water on the plants. When this will, when this particular balloon will puncture, what will happen? All the water will instantly fall down on the surface of the plant or on the surface of the root. ठीक है? तो क्या हो जाएगा? The irrigation process will be completed instantly. So the time lag will be very, very small to observe. So these are what? दोनों तरीके से irrigation हुआ. Energy has been given to this system in two ways. Both of them are possible. This is what happening. This is actually what happening in photoelectric effect. How can you explain this? So to explain this properly, wave theory was not the correct way to explain. तो उसके लिए क्या यूज किया गया? क्वांटम थ्योरी. समझ में आया? अरे वो अतर वो बात नहीं करना, मुझे इसको इरिगेट करना है, खत्म कहानी. डोंट से सर खराब हो जाएगा. कैक्टस का पेड़ है, अब बोल कैक्टस के पेड़ को तेरे को इरिगेट करना है, अब खुश? अब बोलेगा सर कैक्टस के पेड़ को क्यों इरिगेट करना है, उसको पानी की जरूरत नहीं. मान लो पानी की जरूरत है, ठीक है, and then you are just trying to irrigate this. All right, so that can also be explained in this way. Now don't go into the detail of irrigation and cactus and all those things. All right, चलिए आगे बात करते हैं. अरे अरे बैंगन दिखा, ब्रिंजल, ब्रिंजल को तुम्हें इरिगेट करना है, खुश रहो. Now let us talk about the wave nature of light and the wave nature of matter and so on. ठीक है. So what happened when everybody was saying photoelectric effect, everybody was observing photoelectric effect. हमारे एक महानुभाव आए जिनका नाम था डी ब्रॉय. देखो पहले मैं बता देता हूँ वेव थ्योरी ऑफ लाइट क्या बताता है. वेव थ्योरी ऑफ लाइट विल एक्सप्लेन दिस इंटरफेरेंस, डिफ्रैक्शन एंड पोलराइजेशन कंप्लीटली. ओके, दिस इज हाउ द इंटरफेरेंस विल अकर हियर. यहां से जाएगा डिफ्रैक्शन, ठीक है, थ्रू अ सिंगल स्लिट. क्वांटम थ्योरी क्या बताएगा चलो. सो वेयर क्वांटम थ्योरी एक्चुअली हेल्प्स, तो क्वांटम थ्योरी हेल्प्स अस टू एक्सप्लेन फोटोइलेक्ट्रिक इफेक्ट एंड ब्लैक बॉडी रेडिएशंस. ठीक है, तो यहां भी तो है ना बच्चा लोग, आप ध्यान दो. आप if you have studied heat, जो कि मैंने नहीं पढ़ा है, I think आप लोगों ने किसी और टीचर से पढ़ा होगा. So if you have studied radiation in heat transfer, we have studied that amount of a rate of heat transfer from a body is what proportional to temperature. और वो क्या होता है बच्चा लोग, वो बिना even if you are having, let's say if you are having let me use a red color, if you are having a block at temperature T, okay, it doesn't matter what is the medium, it doesn't matter what is the medium, the rate of heat transfer, rate of heat loss from this is what, directly proportional to T to the power 4. How will you explain this part? कैसे explain करोगे? Without any medium, nothing is there, but होगा क्या, it will be radiating this much of energy. ठीक है, this much of energy Q dot by A, and this will be what, directly proportional to T to the power 4. You can also write like this. You can simply write like sigma into T to the power 4. If you are actually writing this A here, you can actually move it here, and then rate of heat transfer can be written as simply A into sigma T to the power 4. So per second, this much of energy this body will be losing. How will you explain this? कैसे इसको explain करोगे? बात समझ में आ रही है? तो इसको explain करने के लिए क्या है बच्चा लोग, quantum theory of light will help you. Otherwise, you cannot explain this black body radiation properly with any of the other theories. तो quantum theory कहाँ का help कर देगा आपको? Majorly photoelectric effect and black body radiations. All right, ये तो आपने देखा ही है, ठीक है. This arrangement you have seen, packet of energy, ठीक है, black body radiation इस फिगर ऐसा दिया है और कुछ नहीं. So thus radiation के बारे में क्या हमें समझ में आया? Radiation have dual energy, particles and wave theory or wave and particles nature. So every radiation have what, dual nature. ठीक है, चलो आगे बात करते हैं. In 1924 हमारे डी ब्रॉय साहब आए. I don't know how to pronounce it. I think I have seen somewhere that we pronounce this as de Broglie. ठीक है, so Louis Victor de Broglie. So he said कि if radiation have dual nature, what about matters? What about matters? He told कि no, matter will also have dual nature. So matter will also have a wave nature, which is not so visible at particular speed, but yes, matter will also have a dual nature. Matter will also show the wave nature. कैसे? तो इसका उन्होंने बाद में एक्सपेरिमेंट से जवाब दिया. So what was his theory? He told particles like electrons, protons, neutrons, etc. have dual nature. Why? Because they have very high speed. तो क्या उनका सजेशन क्या था? What was his suggestion? He suggested, his suggestions were what? Actually based on two arguments. पहला, the nature loves symmetry. If someone asks you what is the de Broglie hypothesis, तो what is that? Nature loves symmetry. ठीक है, अगर पॉजिटिव है तो नेगेटिव है, अगर नेगेटिव है तो पॉजिटिव है, इफ गुड है तो बैड है, ठीक है, लव है तो हेट है. तो हर जगह this was his observation, like nature loves symmetry. So it is not actually limited to radiation only, that radiation will have dual nature. उन्होंने क्या बोला? Matter will also have a dual nature. तो अगर पार्टिकल है तो वेव थ्योरी भी होगा. Okay. Pranav is saying de Broglie looks very funny, sir. Then why do we have one heart? इसके बारे में बाद में बात करेंगे, ठीक है. चलिए. So the two basis physical entities, matter and energy, must have symmetrical characteristics. उन्होंने क्या बोला कि matter and energy they must have symmetrical characteristics. Like अगर matter है तो energy है तो matter है. मतलब they must have some symmetry. All right. In no experiment, matter exists both as particle and as a wave. ठीक है? Simultaneously, the two aspects are actually complementary to each other. ये क्या बच्चा लोग? They are what actually complementary to each other. It is not like this कि both matter exist both as particle and as wave simultaneously. It's not like that. To explain it, if wave theory is not able to explain something, then what will happen? This particle theory will actually help. So if you combine both the natures, you can actually explain all the properties, all the phenomena, all the processes that is occurring in the real life. Okay? So these two aspects are what actually complementary to each other. So what was actually de Broglie hypothesis? What was the relation that he has given? He told that wavelength associated with a particle. Okay? He told the wavelength lambda associated with a particle of momentum p. So what is the wavelength that will be associated with a matter which is having momentum p or which is having a velocity v? ठीक है, तो कैसे उसको explain करेंगे? तो he told कि lambda will be equal to h divided by p, where p is what? The momentum. And how will you write this momentum? M into v. All right, guys. So he has given this relation that lambda will be equal to h by mv or h by p. He has actually done some experiment also. He has taken, he has actually got this value of lambda using some different matters. ठीक है, उसमें lambda को उन्होंने value भी निकाला actually. मैं बताऊंगा आगे देखो. Where m is mass of the particle, v is the speed. The wavelength lambda for matter wave is called as de Broglie wavelength. The wavelength of matter wave is called as de Broglie wavelength. इसको आप ध्यान रखिएगा, ठीक है? Chemistry में भी आप लोगों ने पढ़ा होगा. That is, I'm not going into detail of this. All right. If you talk about a photon, ठीक है? So for a photon, P can be written as h nu by c. ठीक है? P को क्या लिखा गया बच्चा लोग? h nu by c. So from h by p will be equal to c by nu, and this will be c by nu is what? The lambda. And lambda is what? H by mv. So lambda is smaller for heavier particle. If you just think about this, lambda is h by mv. So I can say lambda is smaller for heavier particle. If you increase the mass, lambda will be smaller. Or for energetic particle, large v. If you increase this value of v, what will happen? This lambda will decrease. So lambda will be smaller for heavier particle or for more energetic particle having large v. All right. तो उन्होंने एक्चुअली कुछ एग्जांपल्स दिखाए, ठीक है? अकॉर्डिंग टू de Broglie, some experiments have been done. उनमें से कुछ ऐसा एग्जांपल बाद में लोगों ने डिराइव भी करके बताया. The de Broglie wavelength of a ball, नॉर्मल मैटर जो हम लोग हमारे रियल लाइफ में अवेलेबल है. मान लो इफ यू आर कंसीडरिंग अ बॉल ऑफ 120 ग्राम, ठीक है, और 0.12 kg. ऑलराइट, moving with the speed of 20 meter per second, which is very high speed, but still moving with the speed of 20 meter per second. What is the value of lambda we obtain? If you put all the values of h, if you put the value of p, we'll get the value of lambda as 2.76 into 10 to the power minus 34 meter. 2.76 into 10 to the power minus 34 meter. इसका मीनिंग क्या? बहुत ही छोटा है ना? So this wavelength is so small that it is beyond any measurement. That is why macroscopic objects do not show wave-like properties. इतना छोटा है, just imagine this ना, इतना छोटा है, you cannot even imagine. Just wavelength क्या होता है? Distance between this, right? So just imagine, ये बहुत छोटा है. You can't actually measure this wavelength. So that wavelength will not create any visible effect in real life. तो क्या बोलते हैं? That is why macroscopic objects do not show any wave-like properties. Alright. Second एक example लिया गया. In subatomic domain, the wave character of particle is significant and is measurable. ठीक है? Why? Because mass हो जाता है छोटा, velocity हो जाता है बड़ा. ठीक है? देखिए. So an electron of mass m and charge e. Consider electron of mass m and charge e. Accelerated from rest through a potential v. The kinetic energy k of electron equals the work done. अगर आपको पूछा जाए बच्चा लोग, why this de Broglie wavelength will be dominant or significant in case of electrons, you can simply write this. Lambda will be equal to, आप खुद देख लो कितना बड़ा होगा. Lambda will be equal to h divided by p. तो h divided by p क्या लिखोगे? Mass of the electron into velocity of the electron. All right. Mass of electron is already having an order of minus 31, right? तो वो already बहुत छोटा हो गया. And this velocity will be थोड़ा सा बड़ा. All right. It will not be that high, but this value will what? Very small. So lambda will not be that small that it cannot be measured. So lambda will have what? A significant value. That is why in subatomic domain, the wave character of properties of particles will be what? Significant. Okay. Chaliye. So let us talk about an electron having mass m and charge e. If it has been accelerated through rest through a potential v, then we have to find what will be the value of momentum. पहले तो ये निकालते फिर बाद में लिखेंगे lambda. First, let us find what will be the momentum. तो momentum कैसे निकालेंगे in terms of energy बच्चा? In terms of v, how will you find that? So I can write kinetic energy obtained by the electron will be equal to the potential energy given by the battery or given by the you can say the potential. क्या मिलेगा? Or work done by the potential on the charge, that is charge into potential, that is E into V. This will be equal to kinetic energy gained. So kinetic energy is E into V, and this kinetic energy can be written as E into V. And how can you write half mv square in terms of momentum? How can you write this kinetic energy in terms of momentum? So K can be written as P square by 2m. कैसे मिला P square by 2m बच्चा लोग? तो you must have studied this half into m square v square divided by m. So m square v square is nothing but p square. So you can write p square by 2m is what? The kinetic energy. So kinetic energy can be written as p square by 2m. So p can be written as square root of 2m into k. Square root of 2m into k. If you bring this 2m here, it will multiply here, है ना? And they take the square root. So p will be square root of 2m into k. If you put the value of kinetic energy here, you'll get momentum will be equal to square root of 2me into v. So this is the momentum of an electron. ये क्या हो गया बच्चा लोग? This is the momentum of an electron. If you'll be asked to find out the lambda, so lambda for an electron will be written like this. Lambda for an electron will be equal to h by p, and p is nothing but square root of 2me into v. So whenever an electron is accelerated through a potential v, what is the de Broglie wavelength that electron will show? So answer क्या लिखोगे? That will be written as h by square root 2m into v. We know the value of h, we know the value of mass of electron, we know the value of charge of electron. If you put the value, you are going to get 1.27 divided by square root of v nanometer. तो ये कहानी मिला मुझे किसके लिए बच्चा लोग? So de Broglie wavelength for an electron accelerated through a potential v. ठीक है बच्चा लोग? तो ये फॉर्मूला प्लीज याद रखना फॉर एन इलेक्ट्रॉन, ये आपको यहां भी काम आएगा. And this formula will be helpful to you in chemistry also. If you can recall your chemistry class, this must have been taught to you in chemistry also. पढ़ाया गया है बच्चा? Guys, click yes if you have understood this bhashan. Do you recall this part? Lambda is equal to 1.227 divided by root 7. So root v. पढ़ाया ना आप लोगों ने? Yes, ठीक है. बहुत बढ़िया. तो याद रखना बस इसको, ठीक है? All right. So example लिया गया, if V is 120 volt, what is the value of lambda? As you can see here, if that electron has been accelerated through 120 volt, that is possible, right? 120 volt से मैंने क्या किया? And you can also isolate an electron. You can also get an electron, right? You can get some electron out of metal. If you get that electron and if you accelerate that with a potential difference of 120 volt, see what is the lambda? Lambda कितना मिला? Nanometer में. Nanometer तक तो हम काम करते हैं, एंगस्ट्रॉम तक काम करते हैं. You can measure that. So wavelength is what? The same order as spacing between the atomic planes in crystals. That is why in subatomic domain, the wavelength character of the particle is significant. क्यों बच्चा? ध्यान से पढ़ो, याद करो. वेव थ्योरी मैंने पढ़ाया था. I told कि a radiation or a light will act as what? A wave. Will actually behave like a wave, or will be showing the wave property in dominance when the obstacle or when the hindrance is what? The size of hindrance is comparable or considerable as or with respect to the lambda with respect to wavelength. If the size of hindrance is comparable or considerable with respect to the wavelength, then it will show wave property in dominance. तो wave property क्या कर जाएगा? Dominate कर जाएगा. वो आपको real life में दिखेगा. तो I can say that यहाँ क्या लिखा है देखो बच्चा लोग. What is the order of spacing between the atomic particles? That is nanometer, है ना? ये क्या बच्चा लोग? Nanometer में. और lambda भी क्या मिला? Nanometer में. So the spacing between them and the lambda, they what? Comparable. तो क्या करेगा? ये wave theory को पक्का दिखाएगा, and that will be considerable. That will be dominant. That is why particles like electrons will show the wave nature as well. That is why the particles like electrons will show the wave nature as well. Okay, तो particles, अभी electron भी तो क्या है बच्चा, उसका भी कुछ mass है, that is also a matter, है ना, that is also a matter. So that will have a wave nature also, a particles nature also. When particles nature will be dominant, जब mass बड़ा है, velocity कम है, ठीक है. And when wave nature will be high, when mass will be small, velocity is also ठीक ठाक, okay, or velocity is high also चलेगा. When mass is very small, or if you talk about the lambda, you can actually compare it. All right. So experimental verification of de Broglie hypothesis. अब पूरा chemistry आ गया है, आप लोगों ने chemistry में पढ़ा होगा, उसका थोड़ा सा यहाँ पे कह सकते हो gist दिया हुआ है, glossary summary दिया हुआ है, ठीक है. इसको किसने explain किया बच्चा experimentally? Who has actually verified this? तो Heisenberg का uncertainty principle ने. तो what did he say? So he suggested that it is impossible to determine simultaneously the exact position and momentum of an electron. So he said that he cannot actually locate, or he cannot actually find out, determine the position, exact position and exact momentum of an electron. He has given a relation, that is delta x dot into delta p will be what? Always greater than equal to h by pi. ये क्या था बच्चा? Experimental data था. बाकी कुछ लोग इसको वेरीफाई करके इक्वेशन मिलाने की कोशिश करते हैं, बट वो आपके लाइक दिस इज बियॉन्ड योर स्कोप ऑफ सिलेबस, तो वो हम यहाँ पे नहीं कराने वाले हैं. जस्ट हैव टू रिमेंबर दिस. सो हाइजेनबर्ग्स का क्या है अनसर्टेनिटी प्रिंसिपल? दैट डेल्टा एक्स डॉट डेल्टा पी और इनटू डेल्टा पी इज व्हाट? ग्रेटर देन इक्वल टू h by 4 pi. What is delta x? Uncertainty, change in position, uncertainty in position. What is delta p? Uncertainty in momentum. Why it is not actually possible to locate exact position or exact momentum? आप खुद देख लो. If delta x is 0, if you actually going to find out the exact position of particle, if delta x becomes 0, what will happen to delta p? Delta p will have about what? An infinity, not defined value. H by pi divided by 0 will what? क्या मिलेगा? H by pi divided by 0 will what? And not defined value, right? So then momentum will not be defined. If you have exact momentum, then delta x won't be defined. ठीक है बच्चा लोग? Are you getting my point? चलिए, तो अभी देखिए बच्चा, if delta x is 0, delta p must be infinite in order that product is what? Non-zero. Similarly, if delta p is 0, delta x must be infinite. Okay? अभिषेक, सॉरी बच्चा, अभी नहीं बता सकता हूँ, मुझे अभी कुछ क्वेश्चंस भी सॉल्व करना है, ठीक है? Some other day. Ask me on Saturday, ठीक है? Ask me on Saturday after the class. चलिए. Generally, delta x and delta p are what? Non-zero. Generally, delta x and delta p are what? Non-zero, such that their product is of the order h by pi. तो जनरली क्या होता है? डेल्टा एक्स एंड डेल्टा पाई. ये था क्या बच्चा? देखो यहाँ पे लिखा हुआ है द एक्सपेरिमेंटल वेरिफिकेशन. क्या बच्चा लोग? द एक्सपेरिमेंटल वेरिफिकेशन. स्टोरी अगर केमिस्ट्री पढ़ रहा हो तो बच्चा मैं बता देता यार, अभी फिजिक्स में नहीं बताना चाहता हूँ मैं, टाइम जाएगा, ठीक है? सो डेल्टा एक्स एंड डेल्टा पी क्या है बच्चा लोग? नॉन जीरो, एंड द प्रोडक्ट विल व्हाट? ऑफ द ऑर्डर h by pi. एग्जिस्टेंस क्या था बच्चा लोग? डेफिनेट पाथ का. तो आपने देखा होगा फिगर ऐसा कुछ बना हुआ. हैव यू सीन दिस फिगर? Actually, this was an animation here, but I have converted this into PDF, so that animation has gone. So you'll find a range of position कि आपको यहाँ के बीच में कहीं भी दिख सकता है. You'll have what? A range here. है ना? बुक में मिला होगा आपको. Correct है? चलिए. To help this out, कैसे पता चलेगा where actually particle is? You can actually have a probability. You can actually predict that. Okay, in this range you can find the position. तो उसमें किसने हेल्प किया? तो बॉर्न ने हेल्प किया. तो क्या किया? By Born's probability interpretation, the electron is not localized in any finite region of space. उन्होंने क्या? Probability बताया. ठीक है? The matter wave corresponding to a definite momentum of electron extends all over space. क्या बोला बच्चा लोग? The matter wave corresponding to a definite momentum, एक पर्टिकुलर मोमेंटम का अगर इलेक्ट्रॉन है तो क्या हो जाएगा? Extends all over the space. वो क्या दिखेगा आपको? हर जगह दिखेगा. ठीक है? Because delta p अगर 0 हो गया तो delta x will be what? Infinity. So uncertainty in position is what? Very very high. So if you are having a, let's say, an atom, देखो ये बोर्स थ्योरी को कंप्लीटली क्या करता है? डिस्कार्ड कर देता है. देख लो बच्चा, we said कि यहाँ पे क्या रहेगा? एक पार्टिकल रहेगा. But what does this say? क्या बोलता है कि if a particle will have a particular momentum, what will happen? The probability of this electron to be found is here also, here also, here also, here also, here also. Anywhere it can be found. Anywhere it can be found. That is why Bohr's model of atom जो था हमारा, that is not valid for all the atoms. That was not valid for all the atoms. That was the actually वो basic था पहले बताने के लिए. ठीक है, चलिए. So in general, the matter wave associated with the electron is not extended all over the space. But क्या है बच्चा लोग यहाँ देखो. In general, the matter wave associated with the electron is not extended all over the space. The wave packet corresponds to the spread of wavelength. Wave packet क्या बता रहा है कि this wave packet corresponds to spread of wavelength. Alright, around some central wavelength. तो एक wavelength मान लो if you are having this lambda naught, so plus something delta naught minus something delta naught. So wave packet correspond to spread of wavelength around some central wavelength. The wave packet description together with de Broglie relation and Bond's probability interpretation reproduce the Heisenberg's uncertainty principle exactly. तो to explain this Heisenberg's uncertainty principle आप लोगों को क्या क्या यूज करना पड़ेगा? You have to use this de Broglie relation, you have to use this Bond's probability, and you have to use the wave packet description also. तो सबको मिलाओगे तब जाके ये क्या हो जाएगा? Completely explain हो जाएगा. Or you can say that you can actually reproduce this particular principle properly. So whatever this Heisenberg has said, वो सब actually क्या था? It was combination of de Broglie's relation and Bond's probability. Alright, बच्चा लोग. So this is what a combination of this will explain both of them together. To explain this, you need both the relations, both the theorems or both the suggestions. ये था part बच्चा लोग इसका de Broglie relations का and Bond's probability का and this Heisenberg's principle का, which you must have studied in chemistry. मुझे यहाँ सिर्फ यही बताना था कि what is de Broglie wavelength and how it is related to Heisenberg's uncertainty principle and how this is related to Bond's probability. In physics, you will never be asked from this topic. You will never be asked from this topic. ठीक है? Physics में उससे आपको कोई भी question नहीं पूछा जाएगा. Question will be asked to you from matter wave, from wavelength. ठीक है? Matter wavelength क्या होता है उससे question पूछा जाएगा. This was there in the slide and it was actually related to that. So I have just tried to like give you small data, some small information here. Just for the sake of you can actually relate to the chemistry class. So based on these things, we have some numericals to solve. चलो बच्चों लोग इसका आंसर करो. An electron, an alpha particle and a proton have the same kinetic energy. Which of these particles has the shortest de Broglie wavelength? Which of these particles will have the shortest de Broglie wavelength? You have three particles, electron, an alpha particle and a proton. किसका सबसे छोटा de Broglie wavelength होगा? Don't worry guys, मेरे पास already solution ready है, so I'll give you the solution. Okay, most of you are saying alpha particle. Let us see. Alpha particle, alpha particle, alpha particle. Why बच्चा लोग? Why alpha particle? More mass. Okay. चलिए. So let us see this solution. किसका मिला? Alpha particle का सबसे कम मिला. सबसे ज्यादा किसका मिलेगा? Which one of them will have the largest wavelength? Which one of them? अरे मुझे जल्दी खत्म करना है. मुझे फिर से न्यूमेरिकल पे आना, ऑब्जेक्टिव क्वेश्चन पे आना है प्रतीश. So which one of them will have? Because बहुत छोटा है ना बच्चा. देखो बच्चा. So lambda is what? क्या लिखेंगे? H by square root of 2mk. K is constant, H is constant. So I can say lambda is what? Lambda is what? Inversely proportional to square root of m. So one which will have higher mass will have lower wavelength. One which will have the lower mass will have higher wavelength. तो यहाँ से मालूम चला mass सबसे ज्यादा किसका? Alpha particle का. Mass of an alpha particle is 4 times mass of proton. And mass of proton is 1836 times mass of electron. समझ में आ रही बात? तो सबसे ज्यादा मास किसका हुआ? Alpha particle का. Which one of them will be the lightest? Electrons will be the lightest. ठीक है? So lambda for electron will be the longest one. Lambda for alpha particle will be the shortest one. So this is the relation that you have to remember. Okay? आगे कहीं पूछ देना तो ये करने की जरूरत नहीं होनी चाहिए, आपको याद होना चाहिए. Okay? If you have been asked this relation, you should be able to actually remember this. You don't have to actually again do it. ठीक है? चलो बच्चा आंसर करो इसका. Try to get an answer for this question. What is the de Broglie wavelength associated with an electron accelerated through potential difference of 200 volt? What is the de Broglie wavelength associated with an electron accelerated through a potential difference of 200 volt? Pratish has answered. बाकी लोग जल्दी आंसर करो. Hari Prakash has answered. Priyadarsh, but सबके अलग आंसर्स आ रहे हैं यार. Pratish has given an answer as 1.1 into 10 to the power minus 20. बच्चा अभी देखा था कि when potential difference was 120, we got the answer in terms of nanometer. Pratish, you are increasing the value of V. तो पक्की बात है यार, लैम्डा का वैल्यू तो बड़ा होना चाहिए था, घट गया कैसे? Hari Prakash is saying 0.865 angstrom. Priyadarshini is saying 0.085 nanometer. They are the same actually. Ganesh is saying 0.1 nanometer. Then Khushi 0.88 nanometer. Aditya D is 0.87 angstrom. Gokul 0.86. चलो तो आंसर देखते हैं. Very good guys, keep it up. तो 0.86 or 0.87 angstrom is the correct answer. तो बच्चा सिर्फ वैल्यू तो पुट करना था, right? You have to just put the value. Yeah, no problem Ganesh, it's okay. So you just have to put the value of V as 200, take the square root and get the answer. So 0.868 into 10 to the power minus 10 will be the correct answer. All right. Achha, one thing is very important here, which most of the students will actually miss out. वो miss out क्या करते हैं पता है? Guys, can you guess the blunder that students used to do? क्या blunder करते हैं? What actually they miss out? This nanometer. When they'll be writing the examination, they will think ये मीटर था, एंगस्ट्रॉम था, नैनोमीटर था, वो दिमाग उनका घूम जाता है. Because they also remember a relation like this: 12431 divided by lambda in angstrom in electron volt. तो क्या इसे hodgepodge करते हैं, hodgepodge कर देंगे, mix कर देंगे. You have to remember, if you're writing here 1.227 divided by square root v, then यहाँ पे क्या लिखोगे? It should be what? Nanometer. It is important. Please mark this down. Okay? आप अपने notebook जब बनाओगे तो इसको ऐसे गोल में बनाना and then mark it. गजनी नहीं बनने का, ठीक है? तो गजनी not allowed. तो गजनी लिख के कट करना, ठीक है? So please do that. All right. But चलो try to get an answer for this question. अरे यार वैसे ही बोलना है. Whatever you want to write it so that you should remember that part. गोकुल ठीक है ना, याद करो, कोई दिक्कत नहीं. कोई एक ही बोलूंगा. I don't want to write that here. Otherwise, people will ask me, sir, which one to remember, sir? Now it's confusing, sir. जितना कम information, उतना कम confusion. Less information, less confusion. So more score. चलो बच्चे जल्दी से आंसर करो. Less information, that means कि completing the syllabus. Syllabus should not be left behind. All right, guys, give the answer for this. A particle is moving 5 times as fast as an electron. The ratio of the de Broglie wavelength of the particle to that of electron is 1.8 into 10 to the power minus 4. Calculate the particle's mass. Calculate the particle's mass. Come on, guys, solve it fast. All right, Khushi has answered. Aditi DS has answered. Ganesh has answered. Aditi DS and Ganesh are saying almost same. Pratish is also saying the same value. Khushi is thoda sa offset from the answer. Khushi is saying 10 to the power minus 22. Prashant, ठीक है, almost same ही answer तुम्हारा भी है. Hari Prakash is also saying the same. So most of you are saying the answer will vary like in the range of 1 into 10 to the power minus 27 or something. है ना? चलो देखते हैं करेक्ट आंसर क्या है। 1.012 into 10 to the power minus 27. That is correct. Aditi, you got it. Spot on. Very good. So, but yes, yeah, this is the correct answer. कैसे निकालना है बच्चा लोग? So, for an electron, we know this relation, right? Lambda is equal to h by mv. Since in the question velocity has been related, mass has to be found out, ratio of wavelength is given to you. So you have to use this formula. So m will be written as h by lambda. We have to find m. So mass for electron will be h by lambda for electron divided into velocity of electron. ठीक है? Mass for the object will be written as h divided by mass lambda for that particular particle and velocity of the particle. We have to find mass of the electron, है ना? तो क्या करेंगे? Sorry, mass of the particle. So what we'll do? We actually divide it. तो हम क्या करेंगे? M divided by me will be equal to h divided by lambda v divided by h divided by lambda e into v. So this will go to the numerator. H and h will get cancelled, and finally we'll get m divided by me is equal to lambda e into ve divided by lambda into v. And m will be written as me will be cross multiplied. It will come to this one, this particular relation. So mass of a particle will be me into lambda e divided by lambda into ve by v. और यहाँ से जब values put करोगे, तो first deal with the power of 10 and then deal with this. So 9.11 divided by 9, it will be 1.01. Very good. Aditi has actually has got the approximation very good correctly. तो क्या है बच्चों लोग? 9.11 divided by 9 into 10 to the power minus 27. इल पक्का 1 point something 0 something, right? तो correct है. ठीक है? So correct answer for this is what? 1.012 into 10 to the power minus 27 kg. Which particle has mass in this order बच्चा लोग? Tell me, which particle in an atom have mass in this range? A proton, है ना? Proton का mass इसी range में होता है. Correct है? Very good. बहुत बढ़िया. देखो बच्चा, Davison and Germer experiment is not there in your syllabus. It has been omitted, so I'm not teaching you. However, I have included this part here. You can revise it after the class. और ये मुझे बताने की भी जरूरत नहीं, आप देख लेना एक बार. Summary आप लोगों को पता है. अभी हम लोग काम करेंगे असल वाला, जिसमें चेक किया जाएगा how many of you are actually present here, how many of you are actually mentally absent right now. Give the correct answer for this one. Let me launch a poll. Poll कहाँ गया? MCQ yeah. Come on guys, answer this question. A metal surface is illuminated by a light of given intensity and frequency to cause photo emission. If the intensity of illumination is reduced to 1/4 of its original value, then maximum kinetic energy of emitted photoelectrons will become. एकदम मस्त खतरनाक टफ क्वेश्चन है. Sir, why are you saying this, sir? मुझे कुछ बैधाज मिल रहा है ना. I'm seeing the poll result. From there, I'm telling this. Let us see how many of you get the wrong answer, because I'm not interested in the correct answer right now. The one who will give correct answer, I'm not interested in those guys right now. I'll tell you very frankly. मुझे सिर्फ उन लोगों को पकड़ना है जिनका गलत आंसर आएगा, because ये बहुत टफ क्वेश्चन है. चलो बच्चे जल्दी आंसर करो, तब तक मैं चाय पीता हूँ. Because it is very tough question and you will require an hour at least to solve this. Only 43 of you have answered. डर गए क्या बच्चा लोग? डर के आगे जीत है रे. जल्दी सॉल्व करो. देखते हैं पूजा. So frequency has been reduced to 1/4. Sorry, intensity has been reduced to 1/4. What will happen to the maximum kinetic energy of emitted photoelectron? कुछ लोग बोल रहे हैं सर क्यों भाव खा रहे हो इतना सर. सर करेक्ट आंसर बता दो. तो करेक्ट आंसर बताता हूँ. बच्चा ये टफ था क्या रे? अच्छा रिजल्ट शेयर करता हूँ. रिजल्ट शेयर करता हूँ. What will you tell to these guys? और जिन्होंने आंसर नहीं किया, तुम्हें तो मतलब मैं अंदर से बता रहा हूँ, गोली मार रहा हूँ तुम्हें. बस बच गए तुम्हारे मम्मी पापा के आशीर्वाद से, नहीं तो मर जाते तुम लोग पक्का। अरे फॉर दिस क्वेश्चन इट इज नॉट गुड रिजल्ट यार। For this question, even if one of you is telling wrong answer, it is not good result. इसमें तो 20 of you यार, 20 of you have given wrong answer. That means these 20 guys, इसमें एक आध लोगों का mistake हुआ होगा. They might have been opting for B and like होता है ना ये B का C B का कुछ हो गया. But 20 of you have got the wrong answer. How can you do this? अरे मेरे पे थोड़ा सा तो दया करो यार, थोड़ा रहम करो. Why do you want to kill me? Intensity does not depend on the energy of photon does not depend on the intensity. So if energy of photon does not depend on intensity, how energy of electrons will depend, right? Electrons are going to take energy from photons only, right? So energy of electrons won't depend on the intensity. It doesn't matter how intense the light beam is incident on the metallic surface. All right. Next question. चलो बच्चा आंसर करो. Representing the stopping potential V along y-axis and 1 by lambda along x-axis. For a given cathode, the curve is a straight line, the slope of which is equal to. What will be the slope? Slope क्या होगा? I think yesterday we have solved this, right? कल का ग्राफ याद है आप लोगों को? कल ही हम लोगों ने किया था ना? We have actually solved this question yesterday. Come on बच्चा लोग जल्दी आंसर करो. All right, let us solve this one now. Time ho gaya. Let me end the poll. 38 of you have answered. Only 38 of you have answered. So we have to find the slope in V and 1 by lambda graph. All right. So we know this, that E V naught is equal to E minus phi, है ना? So will be equal to HC by lambda minus phi is equal to E V naught. V naught will be equal to HC by E into 1 by lambda minus phi by E. So I can compare this with Y is equal to mx plus c, where m is equal to hc by E, where c is equal to minus phi by E. Guys, please click yes if you have understood this. I know most of you have given the correct answer, but those who couldn't give the correct answer, please click yes if you have understood this. ठीक है? So correct answer is what? Option. All right. Chalo, let's move on to next question. A surface irradiated with light lambda is equal to 480 nanometer gives out electrons with maximum velocity v meter per second. The cutoff wavelength being 600 nanometer. The same surface would release electrons with maximum velocity 2v meter per second if it is irradiated with a light wave of wavelength. क्या होगा जल्दी बताओ. Come on guys, give the answer. बोल चाहिए? Okay, no problem. Launched. Come on, guys, give the answer fast. So I'm getting few answers in the poll. Okay, Tejas is saying option D. Okay, so when lambda is 480 nanometer, the maximum velocity is V. Cutoff wavelength is what? 600 nanometer. What is this cutoff wavelength, bachalo? What is the meaning of cutoff wavelength? Come on, guys, give the answer. What is the meaning of cutoff wavelength? Bachalo, please give the answer fast. Chaliye, what is the answer, bachalo? So I can see only 61 of you have voted. Sorry, बच्चा. बार-बार मुझे परेशानी हो रहा है कुछ तो. चलिए, so answer करता हूँ मैं. Yeah. So I was talking about this cutoff wavelength, right? Cutoff wavelength is what? This is nothing but the threshold wavelength. That is the minimum wavelength, sorry, maximum wavelength. That is what allowed. Okay. Till which this photoelectric emission will occur. Okay. So let us find the answer now. So when lambda is 480 nanometer, the maximum velocity is V. I will write half into m into v square will be equal to hc by lambda minus hc by lambda naught. Can I write like this? hc को मैं बाहर निकालता हूँ. I'll get 1 by lambda minus 1 by lambda naught. All right. So the same surface would release electrons with maximum velocity 2v. So half into m into 2v ka whole square will be equal to, if it is irradiated with a light of wavelength, we have to find that wavelength. So hc into 1 by lambda prime minus 1 by lambda naught, right? So we have to find what is the value of lambda prime, because this lambda is known to us. This lambda is known to us. Kitna bacha? 480. We have to find what is the value of lambda prime. कैसे solve करेंगे बच्चा? You can actually subtract. If you subtract it, this lambda prime, lambda naught and lambda naught part will get cancelled, and we'll get a subtraction part here. So I will write half into m into 4v square minus v square will be equal to hc into 1 by lambda minus 1 by lambda prime minus 1 by 480. Guys, can I write like this? Clear है सबको? So in this way, I'll try to find out the answer. Very good. तो यहाँ से solve करेंगे बच्चा लोग, क्या मिल जाएगा मुझे आंसर? तो half into m into 3v square, half into m into 3v square. But anyway, guys, tell me, do I need to solve this? Because mass तो पता नहीं मेरे को, तो क्या करना पड़ेगा बच्चा लोग? यहाँ से देखो, I can write this as, थोड़ा सा मुझे दिमाग लगाना पड़ेगा, बेसिक कॉमन सेंस लगाना पड़ेगा. वो क्या है? अरे यार क्या हो रहा है? Or actually I can put the direct value here also, right? Divide भी कर सकते हैं, that is correct. We can divide it also because all this lambda naught is also known to us, है ना? Lambda naught is also known to us, so it will be better to divide it only because anyway when I'm going to subtract it and put the value of half in this square, actually I'll be dividing it only. So if we divide it directly, थोड़ा सा और आसान हो जाएगा, right? So if you divide it, I'll get 4 is equal to 1 by lambda prime minus 1 by lambda naught कितना बच्चा लोग? 600 divided by 1 by 480 minus 1 by 600. Now solve this part. What is the value of lambda will get बच्चा लोग? Lambda prime का value क्या मिलेगा? जल्दी से बताओ. I don't think it is 360. बच्चा लोग कितना आंसर मिल रहा है? Anyone who has done this? Are you sure 360? I don't think so. 360 मिलेगा. It will be 300 बच्चा. It will be 300. ठीक है? लैम्डा क्या मिलेगा? 300. मैंने कुछ वेरीफाई कर लो ना, यहाँ पुट करके देखो. 360 रहेगा तो एलसीएम में कुछ गड़बड़ हो जाएगा बच्चा. इधर देखो. Are you getting this point? So just put the value of 360 here. ठीक है? Then you won't be getting this 4 here. ठीक है? तो approximately आंसर क्या मिल जाएगा? 300 नैनोमीटर. Alright, so option D is the correct answer. Very few of you, only 22 of you have got the correct answer. Only 22 of you have got the correct answer. All right, guys, give the correct answer for this one now. जल्दी से इसका आंसर करो. मैं ही थोड़ा लेट कर दे रहा हूँ हर बार. Come on, guys, give the answer for this one. Five % of the energy supplied to a bulb is irradiated as visible light. So 5% of the energy supplied to a bulb is irradiated as visible light. Okay. How many quanta are emitted per second by a 100-watt lamp? चलो बच्चे जल्दी से आंसर करो. It's actually easy. थोड़ा conceptual बच्चा, थोड़ा ध्यान से solve करना, ठीक है? 11 of you have already responded. Very good. Eighteen of you have responded. Suhas है. Suhas तुमने आंसर चेंज किया बच्चा. C फिर A. What is going on? Pooja, Suhas. Come on, guys, solve this. $26 of you have responded. Why are you coming on there? चलो चलो जल्दी से आंसर करो. Only 40 of you have responded. Chalo, so let us get the correct answer then. Yeah, I think you're correct, Pratish. No problem. I think you're correct only. So 5% of energy supplied to a bulb is irradiated as visible light. Let me end the poll. 47 of you have already answered. How many quanta are emitted per second by a 100 watt lamp? तो 100 watt lamp में क्या है बच्चा, जो बल्ब यूज होगा 5% will be supplied to a bulb. क्या होगा, sorry, 5% of the energy supplied to a bulb is irradiated as visible light, and this visible light will have quanta, will have what, photons. तो क्या करेंगे, 5% of 100 watt is nothing. 5% of 100 watt is nothing but 5 watt. All right, and this 5 watt is nothing but energy, you can say energy of photons per unit time. All right, so energy, we are talking about this only. We have to find what is the number of photons, number of quanta per second being emitted. So I'll write n dot into h nu or hf or hc by lambda, because lambda is given to us. So I'll write n dot into hc by lambda. Why am I writing n dot? N is the number, dot means rate per second. Okay, so n dot is what, number of photons, number of quanta per second. So from this part I'll get n dot is equal to 5 into lambda. Lambda is 5.6 into 10 to the power minus 5 divided by hc. Okay, divided by hc. If you want to simplify it, you can convert this into angstrom, and then you can actually replace this with 12431. Tell me guys, 10 to the power what should be multiplication here? If you want to convert this into angstrom, क्या कितना लिखना चाहिए, बोलो बच्चा लोग. 1 meter is equal to 10 to the power minus 10 angstrom. So 1 centimeter will be equal to 10 to the power minus, sorry, plus 10 है ना, तो it will be plus 8. Correct है बच्चा लोग? 1 meter is equal to, sorry, yeah, correct only, 10 to the power plus 10 angstrom. So 1 centimeter will be equal to 10 to the power 8 angstrom, isn't it? minus 4 क्यों लिखेंगे बच्चा? Correct है ना? Guys, did I commit any mistake? But this will be what, in terms of electron volt, है ना? तो I think मुझे वो करने की जरूरत नहीं है, मुझे SI में ही करना पड़ेगा, right? Because this will give us in terms of electron volt, so you have to convert that into joule also. तो सीधा ही कर दो. तो I think it will actually create more complexity. तो हम क्या करेंगे, सीधा h का वैल्यू लिखेंगे 6.634 into 10 to the power minus 34 into 3 into 10 to the power 8. That's it. Why did I like reverse my decision, bacha? Because if I'll be using that 12431 divided by lambda and angstrom, this value will be what, in terms of electron volt. Then you have to convert that also in terms of joule, SI में काम करने के लिए. So that is why I didn't do that. वो फिर और complexity आता. So it's better to use this only. So solve करो चलो. What is the power here you are going to get? So this will become 10 to the power 34 in the numerator. This will become 10 to the power minus 8 in the numerator. So 10 to the power 34 into 10 to the power minus 13. कितना मिल जाएगा? 10 to the power is what? 10 to the minus 13. So what is the answer बच्चा लोग? जल्दी से बताओ. 10 to the minus 21. Sorry, plus 21. And then you are having 5 into 5.6 divided by 6.634 into 3. तो ये कितना मिलेगा? It will be something 27 or 28. It will be approximately 28, right? 28 or 27. And this will be what? 6.63 into 3. 6.63 into 3. So 6 into 3 is 18. 18 plus plus 1.5, 20, approximately 20, right? 20 something, 21, 22. So you are going to get answer as 1 point something. So if you talk about the units and all, I think option A will be the correct answer. If you take care of all the units and all, yeah, centimeter को meter में भी convert करना है, that is correct. Centimeter को meter में भी convert करना है, that is correct. So minus 2, no problem. ठीक है, that is why I'm getting here 21, right? Minus 22 will be give us 19. देखो इधर, I am getting 10 to the power 34 into 10 to the power minus 8 into 10 to the power minus 7. So this will give us 10 to the power 34 into 10 to the power minus 15. So I'll get 10 to the power 19. तो power क्या मिलना चाहिए? ये मिलना चाहिए. Correct है? So this is the correct answer. So option A is the correct answer for this question. चलो बच्चे जल्दी से आंसर करो इस क्वेश्चन का. Come on guys, give the correct answer for this one. बहुत ही आसान है. And this is the last question. This is the last question for today's class. Let P and E denote the linear momentum and energy respectively. Let P and E denote the linear momentum and energy of a photon. If wavelength is decreased, tell me what will happen with P and E. ये तो बहुत आसान है. So we are ending this with a very simple question, and I expect all of you to solve it and get the correct answer. If P and E denote the linear momentum and energy respectively, if wavelength is decreased. Come on बच्चा लोग जल्दी से आंसर करो. ये बहुत आसान है यार. You should be able to get the correct answer. You should not be committing any mistake in this one. Because if you are committing mistakes in these type of questions, तो examination में बड़ा मुश्किल होगा बच्चा. You won't be able to get good score in your examination. So these kind of questions will be there in your examination. Don't think that ये question ऐसे ही question आता है exam में. So these type of questions have been asked in examination. If you're committing such some mistakes here, then देखो, there is a kind of cutoff in every examination. 40 to 50% questions will be easy to moderate. Moderate only. Easy कह सकते हो आप. 40% will be easy. 20 to 30% will be moderate. ठीक है? And then you can say, yeah, तो बचा कितना बचा? 50 plus 30, 20. So you can say then, rest जो part बचा, 20 to 10%, 10 to 20%, that will be what? So now you're having 50 plus 30, 40 to 50, 20 to 30. So yeah, now I'll be having some rest. 30% to 40% will be what? Tough one. तो ये वाला portion तो आपको complete करना ही पड़ेगा बच्चा. Sometimes it will be more than 60 also, like this year. ठीक है? Sometimes it will be more than 60 also. And these questions come under the category of easy only or moderate only. They will decide the rank, but they will give you the basic rank only na. If you want to qualify, ये तो करना ही पड़ेगा यार. If you're not able to solve these questions, तुमसे ये तो हो ही नहीं पाएगा, कोई नहीं कर पाएगा. Simple सी बात है. ठीक है? चलो बच्चे, let me end the poll here. Only 57 of you have answered, and बहुत ही गलत ट्रेंड है ये. दिखा तो मैं शेयर करता हूं आपके साथ पोल, फिर आपको देख लेना. So P is what बच्चा? P is nothing but H by, or I can say lambda is equal to, देखो अभी कुछ देर पढ़ा है बच्चा आपने. Lambda is equal to H by P, and E is equal to, so I can write this as P will be equal to H by lambda. Energy is nothing but Hc by lambda. We have already studied this. Question भी solve किया. P and E. Decrease the lambda. If you decrease the lambda, what will happen to this ratio? Increases. What will happen to this ratio? Increases. So what should be the correct answer? मैं आपको share करता हूँ result. आप खुद देख लो. Will you consider this as a good result, बच्चा? Only 47% of you have got the correct answer. Only 47% of you have got the correct answer. First of all, very few of you have responded. Out of that, only 47% of you have got the correct answer. या बिल्कुल ये क्या कर रहे हैं लोग? ये लोग क्या कर रहे हैं? So if you talk about the numbers, you can say 14 plus 7, 21, 21%. 30 of you have got the wrong answers. Out of 57 responses, 31 of you have got the wrong answers. It actually haunts me every day. When I take your class in any other classes in physics, ये हमेशा मुझे haunt करता है. Which kind of value addition a teacher can actually do in any class if result will be like this in these kind of questions. अभी teacher क्या कर दे बच्चा? Should I go into medicine? Should I actually create, or should I actually make some medicine for these questions or for physics? कि एक बच्चा tablet खा ले. Why to struggle? Here you don't have to do anything, just to remember these basic formulas, and that too, these relations are already taught to you in chemistry as well. Don't like, you won't believe this guys, but if you try to go into the mind of a teacher, it actually frustrates a teacher a lot. बहुत अंदर से गुस्सा आता है, लगता है क्या किया जाए. And actually it enables, it actually pushes us to judge the student, to judge the parent. Why? Why engineering? Why JEE? Why science? Why can't parent actually think about their students, their kids, that my kid is actually capable of going for any kind of such competitive examination or not? Why do all the parents, why do all the students don't understand this part? Everyone is different, right? तो पहले से पता होना चाहिए after 10th only कि मेरे बच्चे, because these, if you are not able to solve these questions, that means you are not for JEE NEET बच्चा. I'm telling you result here only. नहीं होगा तेरे से. I can't make that happen. Believe me, I will be very, very honest with you. None of the teacher can do it unless you are being given special attention. Special means personal teaching आपको करा जाए. Teacher तेरे घर में ही रह जाए. Every time he'll be teaching you something from the start, from standard 7th, 8th, from standard 5, 6. Because if you're not able to solve this, that means your analytical power is actually very, very low. And that has to be, like you can say, improved a lot. For that, पूरा life चाहिए उसको ठीक करने के लिए. So guys, I believe that to change this struggle of students, you guys also will play a vital role in your society. Try to give your parents a proper advice. Try to give your siblings, your friends a proper advice. Just that don't follow the trend. Don't follow mujhe engineering karna hai because engineers are being treated properly. Just because now doctors will be treated properly, so I have to go for NEET. Just because demand of doctors will be going to increase, so I have to go for medical field and all. Don't do that. First of all, identify your capacity, identify your interest. Don't just get yourself enrolled in science because science looks a kind of respectable stream to you. Please don't do that. I know this will actually affect the revenue of coaching industry, but it will actually create so much of positivity amongst the students. We are going to get so good students. We are going to get so many sincere students who will actually bring some changes. Okay? So with this note, guys, I am going to end this chapter and end today's class. Thank you, Bachalo. Thank you for attending the class. Stay safe, stay healthy, and have a nice day. As I have told you, tomorrow there will not be any physics class. So enjoy, Madi. Bye bye, guys. Take care. Khush rahiye.